All right, welcome to the stream. My name is Kent Quirk. I am streaming not day 8, but in fact day 10. So let me edit this. Of Advent of Code. And that just reminded me that it's wrong on Twitch as well. I might not be able to change it. Oh well, I'll fix it later. Anyway, here I am. And what I'm doing is solving Advent of Code Day 10, and my intention is to solve it in Go. And I'm gonna start now. I haven't streamed the last 2 days. I did solve Day 8 and Day 9. I gave up actually in the middle of Day 8 online because I was having just a bad night for my grade, and took me a little while the next day to finish solving it. It was just annoyingly tedious. That was the one with the basically solving the logical problems of deducing the right segments for a 7-segment display, and it was just a lot of mindless tedium and staring at logic puzzles. And it probably would have been a really terrible stream anyway. Yesterday was a little more interesting, and it ended up being 2 completely different solutions for parts A and B. Part A was finding the lowest value, and it was pretty easy, and finding the lowest values in the square grid. And part B was essentially a flood fill of the grid, and I did it with an inefficient recursive solution that worked fast enough and solved the problem, and so we're done. But let's see what Day 10 has to offer. So I'm going to switch over to my browser. We will take a look at this. Quick note, Honeycomb is one of the sponsors of Advent of Code, and I work for Honeycomb. They've sponsored not only Advent of Code in general, but me in particular, along with some other employees. It's great stuff. So I believe we have a really solid product, and so if you're in a position of needing to do observability, do check them out. Or check us out. So let's look at Day 10. Syntax scoring. Ooh. Syntax error navigation subsystem online, all of them. I love it. I'd like a compiler that said that. Reminds me of the first program I ever wrote. I was 14, it was in the 70s, and I got to hang out in the ops room of a mainframe place, and tried to type in a COBOL program on punch cards. Yes, I'm that old. And so I compiled this, what had to be a 30 lines COBOL program that was designed simply to copy the input to the output. It was the equivalent, it was the COBOL equivalent of cat, except the input was a deck of cards and the output was a printer. When I compiled it, I think I had more errors than I had lines of code. And I remember, I had never encountered a compiler before. I didn't know what it was doing. I remember being really annoyed that it was telling me, you're missing a semicolon right here. And I'm like, well, why didn't you just put it in there for me? So anyway, welcome to programming. And yet I'm still here 40 years later. So, so let's continue reading our little puzzle here. Navigation subsystem is made of several lines containing chunks. There are no more chunks. Each chunk contains 0 or more other chunks. This, by the way, is code for regular expressions or possibly parsers. So let's see if it's something we could theoretically... Oh, it's nested. Ha ha ha. Okay, so we have to show, we have to do nesting. So parsing and nesting is a, like counting anything is something that regular expressions cannot do, or at least clean star style regular expressions cannot do. So we have to have a parser that actually, pushes things on a stack and counts them and pops them off. So this is one of the problems that is possibly trivially solvable in a parser expression language, and a little bit more annoying to solve as a plain old computer program. We're going to try solving it as a regular computer program. Worst case, I could start dragging in my favorite expression generator called PEG, but I'm not going to do that, at least not to start. Let's see where we are. Okay, so what it's telling us is that basically we have 4 matching things: open paren, close paren, squares, curly braces, angle brackets. And we have to find and discard the corrected lines. Yeah, we're just looking for nesting. Oh, this is interesting. So if we can't just reject non-parsing expressions. We have to basically count. We have to build a stack of opens and pull things off the stack as they're closed, and then as soon as we don't see the matching character we're looking for, at that point we stop and say it's busted from here on. However, we may not clear the stack before we get to the end of the line. So let's try that. Take the first illegal character in the line, look it up, total syntax error for those scores. Okay, this is interesting, and our input. All right, so let's first, as always, copy our input. So input number 1, which is our sample input. I'm going to switch back to my editor. And just to make it a little easier on y'all, I'll zoom in a little bit. There. Now you can hopefully see, that might be one too big. So that's my input sample. What just happened? Oh, it got bigger because I hit the wrong key. Let me fix my editor so that you can see me again. Oh wow. What happened here? Okay. Let's try it again. Okay. So you can see the editor, I can see the editor. That's my sample data. And then I'm also going to copy the puzzle input, which is, oh boy, much more complicated. and I'm going to paste that in as well. And it's a bunch of lines. It's 106 lines. I'm going to save that. Okay. And then we'll go to the main program. So we are just going to create a function day10a, and it takes as input lines, which is a slice of string, and it returns an int. And this is just going to get changed to day10a lines. So great, that's our basic parser, or basic, it reads the input file. When we want to do this to input sample for the first thing. And then this is going to do a for_l in lines. And then we're going to parse L score 0, and then what we're doing is adding up the score for each line. So we're just going to say score plus equals Pascal, and then we're going to return score. And then now we need to write the parse function. Yay! Func parse of s string int, and if you'll excuse me, I'm just going to log into Twitch because I haven't since I rebooted my machine, and I just realized that if anybody's talking to me or anything like that, I can't even see it. So let me just find my channel. No, that's not what I want. I am video producer page. That's what I need. Okay. So I know you can't see what I'm clicking on. I'm sorry. I will be back in 1 second. And this is day10. Cool. Okay. And always good. And yes, we're here. Hey, all right. Now back to the puzzle. Here's what we have. We have pairs, which needs to be the possible pairs that we can search for. Well, actually, let's do it this way. Stack is a okay. Expected is a slice of and so we're going to do this for underscore r colon equals range s. So we're iterating over the string, iterating rooms, and we're going to switch on R, and case is left bracket. So yeah, let's just do a big case statement here. This is going to work out pretty well. If we see a left paren, we're going to expected equals append expected and we're going to append that onto it. And then we're going to repeat this for each of the other three pairs. Okay, case left angle bracket, right angle bracket, left square bracket, right square bracket, and curly brace, right curly brace. So we're pushing onto the stack the thing we expect to pop off the stack when we get a right bracket. So case right bracket expected, want is I want to pop the value off expected. So with the last item in expected. So I want is expected length of expected minus 1. And then we want to shrink expected. So expected equals, and we're going to use a slice to remove the last item from expected. Expected up from 0 up to length of expected minus 1. If want is not equal to right brace because that's what we found. Let's say want's not equal to R, then return score what I'm going to say is that score is a map of room to int which has values, and I have to look this up in the thing. So let's just do okay, there's our score map, and then we're going to return once not R, then return score of R. So what that means is that here we can go right bracket. So basically if it's any of these, right paren, right square bracket, and right angle bracket. So if it's any of those, and then just to be, we're going to panic, oops. And if we go through the whole string, then we're going to return 0. So this is range-wise. And then I have a typo here. Oh, expected is okay. So I have my scoring. I have my expected. I create a stack. I parse it, and just for fun. No, okay. I'm just going to try running it for the heck of it. I think that is this. There we go. Go run main.go 26397. I love it when a plugin comes together. We literally compiled and ran it correctly the first time. That feels good. So we're just gonna say that. Now we're gonna try it on input.txt instead. Go run main.go it. 367227 is my result. I'm going to put that into the browser. Submit it. We are one gold star closer. Yay! Alright. Now discard the corrupted lines. The remaining lines are incomplete. Okay, so the instructions here are that we have to fill in the remaining characters. And we do that, we literally have them in our fat little fingers because we've created the collection of expected values. And so we're testing, do we have the right expected value? So all we have to do is go through that list, pop all the expected values off in the appropriate order. And actually, we don't even have to put them back on the string. I was going to say we're going to rebuild the string, and they want us to rebuild the string, but all they're doing is asking us to score it. So literally, all we have to do is take that string we were given, or that expected value array that we have, and walk it backwards, scoring it, and we're done. So, wow, this could be quite clean. So we just, I think what I'm going to do is I'm going to modify this. Okay, so let's go back here. Let's go back to the editor. I'm going to close this for now. I'm going to modify the parse function to return 2 scores. One was the score for part 1, and 2 is the score for part 2. And so I just have to do that. So parse now returns int, so this return is going to return score 0 and 0 because the score for the error side is, we're going to ignore that, but the score for the one we can fix, when if we had an error, we can't fix it. If we didn't have an error, then we can return the proper score here, which we will do. I'm going to do that. And then I'm going to rename this symbol to error score. So we're going to return error score, fixed score. And this is going to do the same thing. We're going to have rename symbol, error score, 0, and we're going to have a fixed score as well. Fixed scores is actually going to be fixed score is going to be a slice event, and actually I can still have day10A and day10B. I can just look at a different part of the parse function. Okay. And then we're going to make a day10B. We'll do fixed scores for day10B. It's not slice of string, it's slice of it. So we're going to say if we got a fixed score of non-zero, then we're going to fix scores equal append fixed scores comma fixed score, and then when we're done, and actually I don't need to say error score because I can say error score, right? Sort dot ints fixed scores. Okay, so I have a number 3. So I have a length. They say it's an odd numbered length, and I need to return the middle value. So the middle value of this is going to be so there's 5. So the length is 5. So divide by 2, and the answer is 2 if you do it as an int. And what I want is actually the number 2. I want the entry at the number 2. So I'm going to return fixed scores of length of fixed scores for 2. So here we just have to calculate the fixed score now. So if I get here, because we're not done, but so I have to iterate in reverse through the expected list. So in this case it's 1, 2, 3, and then I'm going to rename this one to be our scores. Rename scores. So for I is range of expected what the heck is the editor doing? Minus 1 I is greater than or equal to 0 I minus minus then fixed scores, but in this case now I have to create a value of fixed score. Fixed score is 0. Fixed score equals 5 times fixed score plus expected plus fixed scores indexed by expected y. Okay. Oops. This is an error here. Oh, this is a colon equals. And now it's empty. So if I just do a day10b, see if we did that, and once again we'll do input sample, save that, and go on main.go 288957. Did we get that right? 288957. We did. We got it right the first time and the second time. So I feel really great about that. Let's go to input.text. Run it. And we got a very big number, but let's just see if it's correct. I'm going to share this in case it is. That is correct. Yes. All right. That felt good. Felt really nice to kind of nail that one. And not only like have it work relatively quickly, have it work first time, both times. And let me tell you, I've been doing this for 40 years. It doesn't happen that often, but it feels pretty good for it to happen. Part of it is good tools. I love it when the tools tell you have compile errors while you're typing them. So like I never even had to like have the compiler yell at me. It's great. So thank you for sharing, for watching, and I'll see you all tomorrow. Have a great day, everybody.